Okay, good morning everyone. Uh, I hope last week you have a good exercise with your TA. So we still need to have at least three more sections, okay, for the series, and then we complete the chapter 11. So we need now is the power series. Okay, this is this 11.8 in your textbook. So what we have so far, so let me write here. So far in chapter 11, what you did, like in the previous studies, so far we studied the testing, the series, right? Testing, let's say we have the series of the sum of the AN. So we test with some sort of, we have many methods, from divergence test, integral test, and then the comparison test, and then alternate series, what else, the ratio test, and so on and so forth. So we test the series, and we say that it's converged if it is going to have some specific value, or diverge if it doesn't have any specific value, or it's going to be undefined. So now we consider a series, what we call the power series. So power series, let me write here. It's simply, let me just write the definition first. Or maybe let me write in more general. Okay. So if I have a simple geometric series, let's say x with power of n. Okay. We start from n equals 0, which means that x with power of 0, which is 1, okay, and then plus, when n is 1 is x, and then just multiply with x all the terms, right? So x squared, x cubed, x4, and then okay. And we know that this is also, we call the geometric series, with the r is equal to x, right? And we can configure that. If you remember, in geometric series, if we take the ratio, and if this is less than 1, this should be converged. And if this is equal or greater 1, this will be diverges. Right? And then we can change the x with another number. For example, if you simply take this with 1 over 2, then it will be 1 plus 1 over 2 plus 1 over 4 plus that. And we know that we can compute the total numbers, right? We can compute with the ratio, so we can compute with this formula, right, in geometric series. So if the r is just x, then we get that for this one, we get that this will be 1 over 1 minus x. Or if this is the number, then this will be 1 over 1 minus 1 over 2. Okay, or this is equal to 2. Okay. Now the general formula, okay, for the, let me write a little bit down here. So the general formula for the definition for the power series we're going to include some constant Cn, okay, that the Cn will also include in the our series formulation. So this will be C0 plus C1x plus C2x squared plus C3x cubed plus . And we can interchange the Cn with any constant. Okay, we can write with 1, this is where Cn is 1, and then we can also write with x included with numbers, okay? So we have many variations within the power series. But the definitions, the regular definition is just this. Okay. So the power series, we include the power of the variable x. Okay. And we can also write the power series in terms of not x but x minus a. Okay? That will be another formulations that sometimes we are using it in our formula. So we are writing Cn x minus a. Okay. Then we can also expand the same way, but we exchange the x with the x minus a. So what does it mean? This formula for the second one, we say that this is power series in x minus a. This x minus a, you could say that it is going to be centered at a. Okay. So we could say, or we could imagine that this is going to be, let's say we have a line number. Okay, we have a line number, and let's say we have an A in the center. Okay, so we could have some sort of R radius here, or R big R like that, radius there. And this will be A minus R. This is A plus R. So what does this mean is, for our previous series testing, we can say that, okay, this series is converged, and we know the number, right? Maybe 1, 2, 3, any numbers, right? But we know that we have like a limit numbers. Right? But for the power series, within this x minus a, the consequences is we're going to have the convergences as interval. Okay? So we say that we have the radius of convergence, and we say we can have the interval of convergence. So the convergences is not only limited to one specific value, but we do have some radius here. Okay? Because we have an x. Because we have an x, or x minus a in this case. Okay? Which means that in x minus a will be in the center of this interval. Okay? And then it can go the r here and r here. Okay? And that will define the convergences. Okay? So we have an interval of convergences. Okay? So that's what's interesting in the power series. So we are going to have a new variable that we need to find the interval, which is the x. Okay? Usually we are just dealing with the n. Okay? We are limiting something, limiting n to infinite number, right? And then we say that, okay, it's diverged, it's converged. But now we also think on the x, okay, which is the consequences is the interval of convergence. So this is, we call the radius of convergence, and the whole thing here from a minus r to a plus r, this is the interval of convergences. Okay. And then there are some statement here, the theorem, that we are going to discuss. So there are only 3 possibilities for this power series. Okay. There are 3 possibilities. The series converge when x equals a, or the series converge for all x. And then we say there is a positive number r such a series converge if we have this inequality, or diverge if this is happening. But what does this make sense? Okay, so let's see. Maybe I will give you example on how to look at this. Okay, this is the 3 possibility. Okay. Okay, I will be back to this table and the theorem after we finish the examples. Okay, let me give you example first how to see this possibility. Okay. So first is, let's start to have for what values of x does this series converge. Okay. So let's say this is our an, right? So we can write an is x minus 3 with power of n over n. Okay. Now how to take out this this series? Okay. How to take the convergence? Okay. So the first thing is remember that at the beginning I mentioned that we can think the series as a geometry which has the ratio, which means the ratio also related to our ratio test. Right? So remember the last testing method that we have, the ratio test. What we did is we need to find the R, which is coming from these 2 terms, okay? an plus 1 over an. It is the ratio, right? Which means x over 1, which is the x. Okay? So that's what we are going to do. We are going to take that ratio test into our testing. So we have an, so we could take the an plus 1 over an. Okay? Which means this is going to be x minus 3 n plus 1. And this will be n plus 1, and I will directly multiply by reciprocal. This will be n over x minus 3 with power of n. Okay, don't forget the absolute value, because this is the ratio, should be in the positive terms. Okay, now we can cancel this, right, with this, and then we have left this x minus 3. And we can take out the n and leaving the x minus 3 on the absolute value, right? So we can directly write the limit if you want, like in the ratio test, or you can just write as n going to be infinity. Remember that this is we can write 1 plus 1 over n, right? Which this 1 over n going to be 0, and the rest was just 1. So we have in the final results we have this x minus 3. Okay. Okay. Now, how do we make this converge? That's actually the solutions, right? We need to make the x minus 3 converge. What we need to do from the ratio test? How should we proceed from here? How to make this converge? Make it what? So to get to okay, so to be converged, the ratio needs to be yes, less than 1. Okay, less than 1. So we can write the x minus 3 in absolute value should less than 1. Like this, it's going to be converged. Now we can solve this and write like that. So we know that this will be okay. So this will be converged. Okay. But we need to check if we need to include 2 or include 4, okay? Because we only have this without any equal, right? So we have 2 and 4. Then we need to check. Okay? So check when x equals 2. Check when x equals 4. Okay? So it goes here. So we can need to check. So we'll need to check. X equal 2, which means we are going to change the series or exchange the x with 2. So we have -1, right? -1 with power of n. So the series becomes -1 power of n over n. And of course, we still need some testing method from our previous sections. So if you have this -1, then we need to go to alternating series. Okay. What's the requirement for alternating series? You need to make sure that this 1 over n is decreasing, and the second one, the limit, need to be 0. Then it will be converged. Okay. So we need to make sure that an plus 1 is less than an, which is true. We can try some numbers for 1 over n. 1 over 2, 1 over 3, 4 is going to decrease, right? And then the second one need to be check is this should be 0, which is true. 1 over n, we take the limit is 0. So it's converged, right? So this is converged, which means that we need to add equal here. Okay. So then we need to add equal. Okay. And then we still check another one, okay, the x equals 4. So if we check x equals 4, since it is x minus 3, so 4 minus 3, which is 1, right? So we can write, need to check x equals 4. Then we have 1 power of n, it's just 1, right? So it's just 1 over n, which is a harmonic series. So this is harmonic series. I will write directly that this will be diverges. So we don't need to include this into the interval. Okay. So the interval of convergences start from 2, include 2, 2, 4, exclude 4. So we can say interval of convergence is 2, 4, like that. Okay, this is one example. Okay, one example. Okay. So every time you have like a typical power series problem, like just to usually the most frequently asked questions in the power series is asking the interval of convergence, the radius of convergence. The radius is, by the way, this one here. I will maybe write later which one is radius and which one is interval. The radius is 1, okay? And the interval is, we have interval down there. So that's usually what the question typically asks. But how to get to that solution is the first thing. We need to find the ratio, just like in the ratio test. We get to some sort of x equations, x variable equations. And then we need to make sure that we need to make this into a convergent. Okay? So the converge is when this x minus 3 is less than 1, like in ratio test. Okay? And by doing so, we get the interval. Well, the interval is without this equal. So then we need to check whether the endpoints are included or not. Okay? We check one by one. How to check? We just exchange the x inside the series. Okay, so change and then test the series, which means your previous testing method still you need to use that. Okay? You can choose between all of that testing methods. Check the convergence, and if it's converged, then you need to include, like this x equal 2 is going to include, and then we have the new interval, okay, which is the interval of convergence. Okay, that's the solutions. Okay. So this is one of the possibility. Okay. So remember, we have 3 possibilities. So one possibility is we have this kind of like interval. Okay? We have an interval. Okay? Well, you could say like this is A, this is R, this is A minus R, A plus R. Okay? If you remember, I draw the line number. Okay, so this is some sort of those interval. Okay. Okay, now let's move to the second example, second possibility. Okay. So let me write again here questions for web values of x is the this series convergent. So again, we start by taking the identifications, the AN, and then check the ratio. So ratio will be AN plus 1 over AN. Okay. So I will directly write this is n plus 1 factorial and x n plus 1 like that, divided by n factorial x to the power of n. And remember, when we have n plus 1 factorial, this is equal to n plus 1 multiply with n, and then n minus 1, n minus 2, da, 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 da. Or we can write that n plus 1 factorial is n plus 1 multiply with n factorial, okay? Which means that we can write here, we could take this into n plus 1, n factorial, and then x with power of n, and then x, okay? So we can canceling all these components easily. So this will be n factorial, x with power of n. So n factorial cancel, x with power of n also cancel. So we have, at the end, we have the n plus 1 with absolute value of x, like that. So when we take the limit of the n, no matter the series will be, it will be infinity, right? So how to make the series, or maybe this is going to be a little bit complicated, but let me write here. We can write x out excluding the limit. So since this is going to be infinite, then the only way that the limit will multiply, okay, the only way that this component will be converged is by taking the x equaling it to 0. Okay. So when x is not equal 0, because of the limit, then it will be diverged. And x equals 0, this is the only way that this will be converges. So we write here, the only way to be converged. So we can do this, although we have this limit that makes the conditions infinity. But because the x is not included, or we can factorize x outside of the limit, then we can multiply these two components, okay, easily. If something is still in the limit, okay, of course, this cannot be happening. We say that this will be indeterminate forms. But now, since we can exclude x and we can think x in any number, then we can multiply easily. So if x is 0, so the whole equation will make, or will go to the 0 faster than going to be infinite. Okay? I hope you get my point. Okay? So that's why when x equals 0, see, this is the only way this is going to be converged. This is like in one possibility, it says that x equals a. Okay? So a is 0, right? A is 0, so it's like x minus a. A is 0, so the only way to be converged is x equals 0. Okay? Okay, this is the second example. And we have the third example. Let me just write the question first. Okay, you can still write the notes if you want. So for what values of x is the series now is x with power of n divided by 2n factorial. Converge. Okay, so the idea is still the same for all power series. The first thing you need to check is the ratio. So we identify the an. An is x power of n divided by 2n factorial. Okay. So we take the ratio divide these two. So this will be x n plus 1, and need to be careful here. So let me just write 2 and change the n with n plus 1 like that. Okay. And then multiply 2n factorial over x with power of n. So we have actually 2n plus 2 factorial. Okay. Now how does this actually structured in a factorial? So we write here 2n plus 2 factorial is equal 2n plus 2 and then 2n plus 1 and then 2n factorial, right? Okay. So we can use this statement to cancel out the formula. Okay, so we have this formula. So we have, this is x power of n x, and on the bottom we have 2n plus 2, 2n plus 1, and then 2n factorial. This is 2n factorial, and then we have x with power of n. So we can cancel this and that, and the factorial with that. So we can have some sort of 1 over 2n plus 2, and then 2n plus 1, and then x with absolute value. And if we take the limit, since we have this quadratic formula on the bottom side, if we take the infinity here, we take the limit, then it will be 1 over something big, which is, it's going to be 0. So no matter x, any number, it will stay 0, right? So it will be converged for all x, okay, for all x. So we can say that as n going to be infinity, then this statement here this is going to be 0. So the series converges for all x. So we finish the three possibility. Okay. So for convergences, we can have the interval of convergence. We can have the x equal a as the only way the power series to be converged, or it can be converged for all x. But for this three method, all the same steps, same process. Finding the ratio, and then finding which one is to be converged, and then that's it. If it is an interval, you need to check. You need to check the endpoints. If it is included, then you need to modify the interval. Or we can say the interval of convergences for the third one here, we can say the interval of convergences is from all the x like that. Okay. Okay, maybe some of example that I can also show, like the typical problems that we might have in power series. And for some sort of examples that I show you at the beginning here. So for example, this is what we get from the example. We first taking this, right? The radius is 1, because we see in the equation. And at the end, we have the interval, which is including 2, and then 2, 4, but excluding 4. The second one, the only way it's going to be converged is on a single point, x equals 0. So only x equals 0, that is converged. And then the third example, we get all the series going to be infinite, which means that the interval of convergences for x is any x. Right? Any x can be the solution. So this is example 1, 2, 3. Okay, let me give you another example. Okay, another example. So find r, and r is the radius and I is the interval of convergence of series let's say this is sigma maybe try first just to make sure that familiar with the method. So first is finding the ratio, which is the an, then finding the ratio an plus 1 divided by an, and then solve the equation first, simplify, and then take the limits, like the ratio test, take the limits, and then you will get some sort of the x equation that you need to make sure how to get a convergent series from that x, okay, from that x series. Of course, you have three possibilities. It can be a single point of x, it can be an interval, or it can be true for all x. Okay, so it will be converged for all x. It depends on how we get the limit, right? So first, we take the ratio. So write down the an plus 1 divided by an. So we have 3 with power n plus 1, n exchange with n plus 1, so n plus 2. So this will be n plus 1, x plus 2, and becomes n plus 1 and multiply with the 3 n plus 1 like that. And also here is the n x plus 2 with power of n. Oh. Okay. I think we need to solve this for a while. So we have 3n, so we can write 3 power of n and then 3 power of 2, or 9, right? 9, like that. This one is 3 power of n and 3. So we can cancel this with this, right? So we have 9 and 3, we can cancel. So we can have 3 on the bottom side. And then this one is actually x plus 2 power of n and x plus 2, which we can also cancel. So cancel with that, cancel with that. So we have x plus 2. So we have n plus 1 over n. And then we have x plus 2 over 3. Okay. So we can take the x plus 2 over 3 in the front, and we take the limit of this n. So this is, we can say this is 1 plus 1 over n, right? And this is will be just equal to 1. So we ends up with this x plus 2 over 3. Or we can just make sure the absolute value is only x plus 2, because 3 is a constant. So we need to make the equation converge. So converges when the equation is less than 1, right? And then we make it into x plus 2 is less than 3. Now this 3 is our r. Okay, so r equal 3. And then we may write the inequality. So x plus 2. So x is from -5 to 1, right? And what next is check. Okay, so check x equal -5. So -5 is going to be put here. -5 plus 2 will be -3. So this will be n, and then -3 with power of n, and then 3 with power n plus 1, like that. And we need to check, use some method. I think we can write like factorize the 3. So we might have so this will be -3 power of n divided by 3 power of n, which is, we can write -1, right? We can write -1. So n, and then, or maybe write -1 first and then n. Now we can check the divergence test. So check divergence test. Which we take the limit, and it's already doesn't exist. So we say that this will be diverged. And do the same thing with x equal 1. So x equal 1, this will be 1 plus 2, so it will be 3. So this will be n, 3 with power of n, and then 3 power n plus 1. So we can write 1 over 3. 3 power of n, 3 power of n is just, so we still have n. And of course this will be diverged, right? This will be diverged. Also diverge. Also diverge. So the interval of a convergences is -5 less x plus 1. Okay. Okay, I think we are going to end up to here.